Hello, Big Reds. This is part three of the exam review video. Let's get started right away. So, first things first, all right, let's say we have a problem like this, and I want to solve for x. Well, I know that these angles are congruent, and these angles are congruent, so these are similar triangles by angle. So I can make a proportion. I take the small side over here to the small side over here, which is 6. See, these are both the smallest sides. And then the biggest sides have to be compared. So I'm going left to right. So I'm going to keep going left to right. So this becomes 6 over 9. And then to solve this, I can cross multiply. 6 times 6 and then divide it by 9. 6 times 6 is 36 divided by 9. X equals 4. All right. Next problem. Let's see. Oop. Here we go. Tree casts a 20-foot shadow. Here's story problems. So I'm going to start off with a tree. I'm going to cast a shadow. So it's we don't know how big the tree is. Let's say it casts a 20-foot shadow like this. Okay. And then we have a student, MHS student, we'll say, casts a shadow that's 6 feet. And the student is 5 feet tall. Well, the sun shines down at the same angle, so these are congruent, and these angles are congruent, so these are similar by angle. So I can make a proportion. I can say x height over height, x over 5 equals 20 over 6. You can see I went from left to right. Now again, I'm going to cross multiply and solve. So I take 5 times 20 and divide it by 6. 5 times 20 is 100. 100 divided by 6, let me figure that out, is going to be about 16.7. So x is approximately 16.7 feet tall. That's the height of the tree. Okay, next. We have this triangle right here, and actually 2 triangles. And it gives us that the right angle here, and it tells us that BC is congruent to CD, so I'm going to mark that, congruent. Also, I know they share the side in the middle, so this is congruent. So first of all, are these 2 triangles congruent? Yes, they are congruent. How are they congruent? Well, if I look at one triangle at a time, I have side, angle, side. The angle is between the 2 sides. And on this one also I have side, angle, side. So it's SAS. Okay. Then now to write a congruent statement, I'll start with the left triangle first. We'll say ACB is congruent to triangle. Now if I start with AC in this triangle, I'm going to start with AC in this triangle because they're congruent, right? So ACD. You can see the corresponding parts are congruent. BC is in the same position as CD. You see they're both in the back positions. That's how I could check to see if that congruent statement is correct. Okay, moving right along. Okay, let's say we have a triangle like this. How would these be congruent? Well, we see that these 2 sides are congruent, these 2 sides are congruent, and they share the side in the middle by the reflexive property, so they're congruent by side. Okay, going on to this one. Okay, you can see we have 2 triangles. These 2 angles are congruent, these 2 sides are congruent, and we have vertical angles in the middle that are not marked, but we know vertical angles are congruent. So if I look at just one triangle at a time, I have angle, side, angle, ASA. So that's how those 2 triangles are congruent. All right, let's go on some properties about triangles. Okay, let's say we have a triangle, right triangle. And let's say this angle right up here is 55 degrees, and I want to figure out what x is. Well, a couple ways I could do this. One, I know that all the angles in a triangle add up to 180. So I could take 90 plus 55 plus x equals 180. Or 145 plus x equals 180. If I add these 2 numbers together, and then if I subtract 145 from each side, I get x equals 35 degrees. Another easier way I could do it is I could just take 90 minus 55, because I know these 2 angles add up to 90. and that's going to give me 35 degrees as well. All right, let's say now I have a triangle that looks like this, and let's say these are sides are 15, and this is let's say this is 40 degrees up here, and I want to figure out what these two angles are. Well, I know this is an isosceles triangle because these two sides are congruent. That means these two base angles have to be congruent as well. So an easier way is I know that angles in a triangle add up to 180. So I could take 180 minus 40 gives me 140 degrees. Then I know each of these angles are congruent, so I could divide this by 2 to get 70 degrees each. Each of those angles is 70 degrees. Okay, let's go on to another triangle problem here. Let's say triangle here. We have triangle, we'll say ABC. And let's say this triangle has side lengths that are all 7. And we want to identify this triangle. Well, all the sides are congruent is called an equilateral triangle. Equilateral triangle. Yep. Okay, next, let's go on to another triangle problem, shall we? So let's say I have a triangle that looks like this, and let's see, I have this angle is, let's see, 2x plus 3 degrees. This is 3x plus 1 degrees, and this is 2x minus 7 degrees. And I want to solve for the measures of the angles to the nearest tenth of a degree. So first of all, I know the measures of these all add up to 180. So I could take 2x plus 3 plus 3x plus 1 plus 2x minus 7 equals 180. Then I combine like terms, 2x and 3x and 2x. That gives me a total of 7 x's. Then I add 3 plus 1, which is 4 minus 7 is minus 3 equals 180. Add 3 to each side. I'm left with 7x equals 183. And I divide by 7. Let's see, and so I get 183 divided by 7 is x is approximately 26.1 degrees. Okay, so this is a decimal. So now I have to plug it into each of these angles. This one is 2 times 26.1 plus 3. This one is 2 times 26.1 minus 7. And this is 3 times 26.1 plus 1. So I do that. 2 times 26.1 is going to be 52.2 plus 3 is 55.2 degrees. This is going to be 52.2 minus 7 is going to be 48. Oh, I'm sorry, that's not right. Sorry. 52.2 minus 7 is going to be 45.2 degrees. And this is going to be 26.1 times 3 plus 1 is going to be 79.3 degrees. Those rounded to nearest tenth. Okay. All right, this is the end of part 3. So see you on the next part.